Hello, welcome to GATE 2017 Chemical Engineering paper. We will solve only the thermodynamics and fluid mechanics part. Question number 7 is, as per sequence in question paper, is water is heated at atmospheric pressure from 40 degrees Celsius to 80 degrees Celsius using two different processes. In process 1, heating is done by a source at 80 degrees Celsius. In process 2, the water is first heated from 40 degrees Celsius to 60 degrees Celsius by a source at 60 degrees Celsius. Then from 60 degrees Celsius to 80 degrees Celsius by another source at 80 degrees Celsius. Identify the correct statement. Option A, enthalpy change of water in process 1 is greater than the enthalpy change in process 2. Option B, enthalpy change of water in process 2 is greater than enthalpy change in process 1. Option C, process 1 is closer to reversibility. Option D, process 2 is closer to reversibility. So in process 1, the water is heated from 40 to 80 Celsius by using 80 degrees source. Okay, 80 degrees Celsius source. So the temperature difference of the water is 80 to 40 is large as compared to in second process where the water is heated from 40 to 60 by a source of 60 and then 60 to 80 by a source of 80. So here the temperature difference between these sources and things are small. So the process 2 is closer to reversibility. So lesser the temperature difference, higher will be the reversibility. So answer is T. Next, in a venturimeter, delta P1 and delta P2 are the pressure drops corresponding to volumetric flow rate Q1 and Q2. If Q2 by Q1 is 2, then delta P2 by delta P1 equals option A 2, option B 4, option C 0.5, option D 0.25. So in venturimeter, Q is directly proportional to AB, where A is area of throat and V is velocity, and velocity is directly proportional to root of H. H is your head. So Q2, if we take two cases, discharge for first case is Q2 and discharge for second case is, first case is Q1 and for second case is Q2. So Q2 by Q1 is equal to root H2 by H1. And H is directly proportional to delta pressure or change in pressure. Okay, because this is your head and pressure is rho GH. So H is directly proportional to delta P. So Q2 by Q1 will be equal to root delta P2 by delta P2, and delta P2 by delta P1 is equal to 2 square, or Q2 by Q1 is equal to as delta P2 by P1, because Q2 by Q1 is your 2, so delta P2 by P1 will be your 4. So this is given, so answer is option B. Next, the thickness of laminar boundary layer over a flat plate varies along the distance from the leading edge of the plate. As the distance increases, boundary layer thickness increases. Option A, boundary layer thickness, option A increases, option B decreases, option C initially increases and then decreases, option D initially decreases and then decreases. From Black's equation, we have delta is equal to 5x by Rex, where x is the distance from the edge of the plate and delta is boundary layer thickness. So we can see that and Rex is rho u x by mu, and so this quantity is constant. So delta is equal to root x. Okay, so option is, because here is x, here is root x, so it will be root x. So option A is the right answer. Next, the one-dimensional unsteady heat conduction equation is rho Cp curly T by small t is equal to 1 by r raised power n curly by curly r raised power n k curly T by curly r, where T temperature, small t time, r radial position, k thermal conductivity, rho density, and Cp specific heat. For the cylindrical coordinate, coordinate system, the value of n is above in the above equation is option A 0, option B 1, option C 2, option D 3. So for Cartesian coordinate n is 0, for cylindrical coordinate n is 1, and for spherical coordinate n is 2. This is a general equation of heat conduction, okay, unsteady heat conduction. So answer is option C. Sorry, option cylindrical coordinate, option B. Next, in a heat exchanger, the inner diameter of a tube is 25 mm and its outer diameter is 30 mm. The overall heat transfer coefficient based on inner area is 360 watt per meter square. Then the overall heat transfer coefficient based on the outer area rounded out to nearest integer is dash watt per meter square. Inner diameter of tube is di. Inner diameter of tube di is equal to 25 mm. Outer diameter of tube is d naught is equal to 30 mm. Length of tube is L, and ui is given as heat transfer coefficient based on the inner area 360 watt per meter square, and u naught is heat transfer coefficient based on outer area. So heat transfer is ui ai delta t, and if we consider outer part, then it is u naught a naught delta t. So delta t will cancel out, and area is inner area is pi di l, and outer area is pi d naught l. So this is your 360 into 25, and this is 40 into 30, that is u naught is equal to 300 watt per meter square per degree Celsius. Okay. Next, a propeller diameter d is equal to 15 meter rotates at n is equal to 1 revolution per second. To understand the flow around the propeller, a lab scale model is made. Important parameter to study the flow are velocity of the propeller tip v is equal to pi n d, and diameter d, and acceleration due to gravity. The lab scale model is 1 by 100 of size of actual propeller. The rotational speed of lab scale model to the nearest integer should be. So given that v is equal to pi d, and so it means v is directly proportional to diameter and rpm. Okay, and suppose, and so v is also the speed of the propeller is also proportional to input velocity, and input velocity is directly proportional to root h. Okay, so it means v is directly proportional to root h, and v is directly proportional to dn also. So dn is directly proportional to root h. So n is directly proportional to root h by d. So now for first and second condition, n1 by n2 is root h by h1 by root h2, d2 by d1. As scale is given as 100, so d2 by d1 is your 100, and h1 by h2 is your, again this is given. Head will also be, because scale model is 100, so that will also be 100. So answer is your, as n2 is 1 rpm, so n1 will be 10 rpm. Because h1 by h2 is